Most people think AI competition is about better models, but this chart shows something more important. AI is now constrained by how chips are physically assembled. CoWoS dominates today. CoWoP is trying to cut cost. CoPoS is trying to break physical limits. I'm Bevis Lee. With a background in engineering and EU market systems, I'll break this down from a system and economic perspective, not just technology. By the end of this video, you'll know which technology matters now, which one scales, and which one actually wins. Slide 1. Hook. The bottleneck has moved. The dominant narrative in AI today is still centered around model capability, larger parameters, better architectures, more data. However, this narrative is already outdated. The real constraint has shifted, and it is no longer algorithmic. It is physical. More specifically, it is about how chips are packaged and interconnected. In previous decades, Moore's law defined progress. Shrinking transistor sizes delivered predictable gains in performance. But as we approach the physical limits of semiconductor scaling, the industry is entering a new phase. Performance is no longer primarily determined by how small transistors can get, but by how efficiently multiple chips can be integrated into a single system. This is where advanced packaging enters the picture. Technologies like CoWoS, CoPoS, and CoWoP are not incremental improvements. They represent fundamentally different approaches to solving a new bottleneck: interconnect density, memory bandwidth, and system-level integration. Modern AI workloads, especially large language models and generative AI, require massive data movement between logic chips and memory. High-bandwidth memory, HBM, is no longer optional. It is essential. But integrating HBM efficiently requires extremely advanced packaging techniques. This shift marks a structural transition in the semiconductor industry. The value is moving from front-end fabrication to back-end integration. Packaging is no longer a secondary process. It is now the primary determinant of system performance. In other words, the battlefield has moved. The companies that understand and control packaging technologies will define the next generation of AI infrastructure. This is not just an engineering problem. It is a strategic one. Slide 2. Context. Why this matters now. To understand why advanced packaging has become so critical, we need to look at the demand side. Companies like NVIDIA and AMD are no longer simply designing chips. They are designing entire computing systems, optimized for AI workloads. These workloads are fundamentally different from traditional computing. Instead of being compute-bound, they are increasingly bandwidth-bound. The speed at which data can move between processors and memory has become the dominant performance constraint. This is why high-bandwidth memory is now integrated directly next to GPUs. However, this integration is extremely complex. It requires advanced packaging technologies capable of handling high interconnect density, thermal management, and signal integrity. At the same time, supply constraints are becoming more severe. TSMC, the global leader in advanced packaging, has its CoWoS capacity fully booked years in advance. This creates a structural bottleneck in the entire AI supply chain. The result is a shift in competitive dynamics. It is no longer enough to design a powerful chip. Companies must also secure access to advanced packaging capacity. This transforms packaging from a technical consideration into a strategic asset. In this context, CoWoS, CoPoS, and CoWoP are not just technologies. They are competing solutions to a system-level constraint. Each represents a different approach to balancing performance, cost, and scalability. Understanding these trade-offs is essential, not only for engineers, but also for investors, entrepreneurs, and policymakers. Because the outcome of this competition will determine how AI scales globally. Slide 3. System breakdown. 3 architectures. At a high level, CoWoS, CoPoS, and CoWoP represent 3 distinct architectural philosophies in advanced packaging. CoWoS, or chip-on-wafer-on-substrate, is the current industry standard for high-performance AI chips. It uses a silicon interposer with through-silicon vias, TSVs, to connect logic dies and memory. This allows for extremely high interconnect density and tight integration with HBM. The result is unmatched performance, but at a very high cost. However, CoWoS has a fundamental limitation: the reticle size of silicon wafers. This limits how large the interposer can be, and therefore how many components can be integrated into a single package. As AI models continue to scale, this becomes a critical constraint. CoPoS, or chip-on-panel-on-substrate, takes a different approach. Instead of using circular silicon wafers, it uses rectangular glass panels. This allows for much larger packaging areas and significantly higher utilization rates. In theory, CoPoS can break the reticle limit and enable much larger superchips. However, CoPoS is still in development. It faces challenges in manufacturing precision, material stability, and process maturity. While it offers scalability, it is not yet ready for mass production. CoWoP, or chip-on-wafer-on-PCB, focuses on cost and simplicity. By eliminating the ABF substrate and integrating directly onto a PCB, it reduces manufacturing complexity and improves thermal efficiency. This makes it attractive for cost-sensitive applications. Each of these architectures solves a different problem. CoWoS maximizes performance, CoPoS maximizes scalability, and CoWoP optimizes cost. The competition between them is not about which is better in absolute terms, but which aligns best with the evolving demands of AI. Slide 4. Framework. 3-axis competition. To analyze these technologies systematically, we can frame them along 3 key dimensions: performance density, scalability, and cost efficiency. CoWoS dominates in performance density. Its silicon interposer enables extremely fine interconnects, allowing for high-speed communication between logic and memory. This makes it ideal for training large AI models, where performance is critical. CoPoS, on the other hand, is designed for scalability. By moving to panel-level packaging, it significantly increases the available surface area. This enables larger system integration and better manufacturing efficiency. In a world where AI models continue to grow, this scalability becomes increasingly valuable. CoWoP focuses on cost efficiency. By simplifying the packaging structure and removing certain components, it reduces both material and manufacturing costs. It also improves thermal performance, which is critical for maintaining system reliability. These 3 dimensions, performance, scale, and cost, form a strategic triangle. No single technology currently dominates all 3. Instead, each occupies a different position within this space. This suggests that the future of AI hardware will not be defined by a single dominant design. Instead, it will likely involve a layered architecture, where different packaging technologies are used for different applications. Understanding this framework allows us to move beyond simplistic comparisons and focus on strategic positioning. The key question is not which technology is best, but which one aligns with the specific constraints and objectives of a given use case. Slide 5. Case study. Why CoWoS wins today. Today, CoWoS is the clear winner in high-performance AI applications. This is largely due to its adoption by companies like NVIDIA, particularly in products such as the NVIDIA H100. The reason is straightforward. CoWoS provides the highest interconnect density available today, which is essential for integrating multiple HBM stacks with a GPU. This enables the massive memory bandwidth required for training large AI models. However, this dominance comes at a cost. CoWoS is extremely expensive to manufacture. The use of silicon interposers, combined with complex assembly processes, results in high production costs and lower yields. More importantly, CoWoS is constrained by reticle limits. This restricts the maximum size of the interposer, and therefore the scalability of the architecture. As AI systems grow larger, this limitation becomes increasingly problematic. Despite these challenges, CoWoS remains the best available solution for high-end AI today. This is why TSMC's CoWoS capacity is fully booked, creating a bottleneck in the supply chain. This situation highlights a key insight. Technological superiority does not guarantee long-term dominance. CoWoS wins today because it solves the most immediate problem, but it may not be the solution that scales into the future. Slide 6. Numbers. The economics behind the shift. When we look beyond the technology and examine the economics, a different picture emerges. CoWoS, while powerful, suffers from low utilization rates due to the circular nature of silicon wafers. In contrast, panel-based approaches like CoPoS can achieve significantly higher utilization, often approaching 90%. This has a direct impact on cost efficiency. Additionally, CoWoP offers potential cost reductions of 30 to 50% by eliminating certain components and simplifying the manufacturing process. This makes it highly attractive for applications where cost is a primary concern. Another important factor is yield. As packaging complexity increases, the probability of defects also increases. This leads to higher effective costs as more units fail during production. These economic factors are critical because they determine scalability. A technology that is technically superior but economically inefficient will struggle to achieve widespread adoption. In this context, the future of advanced packaging will be shaped not just by engineering breakthroughs, but by cost structures. The technologies that can deliver acceptable performance at lower cost will have a significant advantage. Slide 7. So what? Market segmentation. The implication of this analysis is that the market will not converge on a single packaging technology. Instead, it will segment into different tiers. At the high end, CoWoS will continue to dominate, powering flagship AI systems used by major tech companies. These systems prioritize performance over cost and are willing to pay a premium for the best available technology. In the mid-tier, CoPoS has the potential to enable large-scale AI infrastructure. Its scalability makes it suitable for hyperscale data centers, where efficiency and throughput are critical. At the lower end, CoWoP could become the preferred solution for cost-sensitive applications, including edge AI and smaller-scale deployments. This segmentation reflects a broader trend in technology markets. As systems become more complex, different solutions emerge to address different needs. There is no single best technology, only technologies that are better suited to specific contexts. Slide 8. Decision: what to watch. From a strategic perspective, the key question is where to focus attention and resources. In the short term, CoWoS remains the most important technology to watch. Its capacity constraints will continue to shape the AI market, creating both risks and opportunities. In the medium term, CoWoP represents a potential disruption. If it can deliver meaningful cost reductions without significant performance trade-offs, it could gain rapid adoption. In the long term, CoPoS is the most promising. Its ability to break reticle limits and enable large-scale integration positions it as a potential foundation for next-generation AI systems. For investors, this means tracking capacity expansion and adoption timelines. For engineers, it means developing expertise in advanced packaging techniques. For entrepreneurs, it means identifying opportunities in cost reduction and system integration. Slide 9. Closing: the real winner. In conclusion, the competition between CoWoS, CoPoS, and CoWoP is not about choosing a single winner. It is about understanding how different technologies align with different constraints. CoWoS wins today because it delivers the highest performance. CoWoP may win in cost-sensitive segments. CoPoS has the potential to win in scalability. Ultimately, the real winner will be the technology that enables AI to scale, both physically and economically. Because in the end, AI is not just about intelligence. It is about infrastructure. And infrastructure is defined by constraints. Whoever solves those constraints will define the future.